We started the semester discussing hazards, risk, and dose response. We described the importance of xenobiotic metabolism and bioaccumulation for the prevention of toxic effects. We reviewed and discussed the literature related to foodborne toxins from sources including plants, animals, as well as natural and synthetic chemicals. While many of these previous topics were governed by chemistry and biochemistry alone, we now arrive at a distinctly human topic: ethics. For the purpose of this video, I will broadly define ethics as the moral values that drive decisions. Wait, ethics in toxicology? I thought we were talking about science, not morality. Let's consider two areas, among many, where food, toxicology, and ethics intersect: animal testing and economic pressures. First, let's talk about animal testing. Knowing that all food components, even essential ones like protein or vitamin C, can be toxic at some dose level, isn't it important to know what level that might be? What about carcinogens like acrylamide or caustic cleaning agents like sodium hydroxide? I think that most people across the world would agree that it is vitally important to know just how toxic a chemical substance might be. In fact, if you examine safety data sheets for many common chemicals, including ethanol, you will find LD50s and other estimates of dose-response toxicity listed. When we move to the question of how to test for toxicity, however, this is where the controversy arises. How are these values determined? For the most part, these values are estimates based on animal studies involving large numbers of animals, including rodents, rabbits, dogs, and non-human primates. We could argue over whether those studies were ethical to do in the past, but let's present a question directly to you right now. Is it ethical to determine the toxicity of a particular substance if it involves continued animal testing, especially if that animal testing results in the suffering or death of an animal? For example, a 2-year study to determine the toxicity of one chemical compound might involve over 3,000 animals. The increasing consideration of and concern for animal welfare over the last 3 decades has led to the concept of the 3 R's: reduction, refinement, and replacement. Reduction means a decrease in the size of animal studies. Reduction can be accomplished in several different ways, including the use of non-lethal technologies such as imaging or gathering multiple blood, urine, fecal, or tissue samples from a single set of animals. Refinement refers to the use of only those animal models with direct application to humans. This is a response to default animal models, often using rodents, that may have had little or no relevance to human disease. Today, some animal models use genetic modifications that more closely mimic human disease. In other cases, ectopic models can be used, in which human tumors can be grown on the surface of an animal's skin, making any observed anti-tumor effects more relevant. Replacement refers to the use of any number of technologies, including non-living simulated skin or membrane systems, cell culture models, embryos at very early stages of development, and computer modeling to predict the outcome of toxicity in humans. In some cases, humans themselves can replace animals if they are given microdoses of test compounds, far below the levels likely to cause harm, but at high enough doses to cause tiny but still measurable metabolic responses. It may not be possible to completely replace animal testing based on current technology. In that case, efforts are directed to partial replacement of animals until more advanced methods allow for complete replacement. Now let's talk about economic pressure. Companies large and small are engaged in a continual struggle for survival and supremacy in the market. The need to be first to market, to increase market share, and to maximize profits for stakeholders and stockholders creates tremendous economic pressure. Throughout documented history, this pressure has often resulted in the adulteration of food with all manner of cheap, inferior, or even toxic ingredients by unscrupulous individuals. Examples include chalk in bread to improve color, the addition of burnt wood in wine to create the appearance of aging, and as Upton Sinclair documented, the mixing of spoiled meat into sausage. According to a 2011 review published in the British Medical Bulletin, the global market for food additives exceeds $30 billion US. Does this large amount of money automatically mean that companies are cutting corners? No, It does not. It does, however, indicate a temptation for cutting corners. Most additives are used for either flavor or texture effects. Many of these were evaluated for safety decades ago. To connect back to the previous topic, should animals be used for those reevaluations? Like companies, universities and the scientists that work for them are also driven by economic pressures. Universities must continually seek out new funding sources in the form of government grants and endowments. They must also compete with other universities for the prestige of new discoveries and recruit new talent. For professors, the pressures on universities translates to pressures to publish, to write grants, and to demonstrate the impact of their work. Any human endeavor, especially when it involves competing interests, poses the risk of a breach of ethics. As scientists, we have a dual responsibility, not only to discover new knowledge, but to act ethically.